So we're continuing with our discussion of how to draw ray diagrams. This is what I want you to start with. You're going to set up an X and Y axis, mark an F on both sides of the lens, and 2F exactly twice the distance on each side too. I've done this on my own paper already. So I've got some graph paper that I managed to find here. If you don't have graph paper, you're going to need to make sure that these distances are exactly the same. So I've got my F. For me, that's 5 away from the origin. F prime over here, 5 away on the other side. 2F, 10 away. 2F prime, 10 away. My lens is the right height. I've made it the same height, top and bottom, so we're going right through the center of the lens. Because all that's going to be important because of the way that this piece of glass that we're representing in a page here is going to bend the light. If you're working with a ruler, you'll need to make measurements, right? If you can't do that, you'll need to take another piece of paper and you can say, okay, this right here, this is going to be my 5 inches. 1 5-inch, and then there's the 2F, F prime, 2F prime. One way or another, you've got to get this right, otherwise you're wasting your time. All right, so let's make this work. Pause when you need to catch up. All right, so we're going to place an object at 2F. I'm going to put an arrow there. I'm going to pause recording and then show you my arrow. I'm going to make my arrow maybe 3 graphs on the graph paper, or 3 squares on the graph paper high. For you, make it maybe an inch high, something like that. But give some certain distance because we need to know how big it's going to be over here. So you can see on my recording here, down in the frame, I've put my arrow at 2F. It's 3 blocks high. Let's see what we want to do next. First thing we're going to do is draw a line straight to the y-axis, then draw the line from the y-axis through the focal point on the other side of the lens. That's straight to the y-axis, and then watch the animation down over here. Let's see if I can move this up here. Hopefully that'll move it on your screen as well. All right, I'm going to do that on my graph paper. All right, so you can see on my graph paper, that's exactly what I've done. It should look the same for you. Let's see if you can do full screen. It should go to 3 blocks high, because this was 3 blocks high, passes through the origin, and what you should notice is that it should stop right at 3 boxes below down there. Right up here, that's 3 boxes. That's what we're going to see because of this special case when images are projected through a lens at exactly twice the focal length. Let's keep going. Next step, draw a line through the focal point, F, to the axis. Then go straight on the other side of the lens. All right, so we're going to go down from the top of the object, some arbitrary point, through the focus, down to the other side, and then we're going to draw straight out. Okay, I'm going to do that on my paper now. So you can see I've done that on my paper as well. And you should notice that we're going from there through the focal point. It should hit at exactly 3 below. 3 below this origin point. Your geometry teacher can tell you why that is exactly. And then it should go straight across. Mine's actually a little bit low. It should go on that 3rd line below. I didn't make mine as accurately as possibly I could have. From here, we're going to draw a line through the origin, ends up at the same spot. Now, here's the important thing to know. Objects at 2F produce a real inverted image at 2F prime, and there it is. I'm going to go ahead and draw that in on mine so you can see what it should look like on your paper. All right, so I've got my image drawn in. I should have put this 2F prime up on the top, so mine's kind of ugly looking. Let's learn. Oh, and you've got my line right through the origin, and these all intersect at the same spot down and over here. This image over here is real because it can be projected onto a screen. The opposite of this would be a virtual image which can't. So this can be used for things like movie projectors or how glasses work, or the lens of your eye works to put an image on your retina. The image is inverted, upside down from where it was before. You may have heard people say that our eyes see everything upside down, but our brain turns it around for us. That's, again, because of how lenses work. And this object is neither magnified nor reduced. It's the exact same size as this object. And if you take your ruler and measure it, you can see that. That's the sort of question you're going to have to answer on your test. I'm going to go ahead and stop this video, and then I'll go through the other ray diagrams in the next video.